Hello, my name is Ubuntu Pure 19 CS1056, and today I'll be explaining my operating system lab experiment number 6 on classic problem synchronization using Cephalopods. So the aim of this experiment is to write a program to simulate a concept reader-writer problem using C or Python. Writing a program to simulate producer-consumer problem using Cephalopods using C or Python, and to write a program to simulate the concept of dining philosophers using C or Python. So in Cephalopods is a synchronization tool that provides more sophisticated ways than Murex logs for process to synchronize their activities. So the bounded buffer problem slash producer consumer problem is a common paradigm for cooperative process. A producer produces or process produce information that is consumed by a consumer. One solution for this problem is that we use shared memory for both producer and consumers uh, to allow them so for to allow the producer and consumer to run concurrently, there must be a buffer item that can be filled by the producer and emptied by the consumer. This buffer will reside in a region of memory that is shared by the producer and the consumer. Producer can produce simultaneously while consumer can consume if we use this buffer method. Uh, so- and through this method, they can be synchronized so that the consumer cannot consume an item that has not yet been produced by the producer. So move on to the more problem. Uh, the code the code for the more problem is as follows, and uh, the output screenshot has been taken here. Now moving on to the data structure problem. A data set is shared among number of concurrent processes, and readers only read the data. They cannot perform edits, while writers can both read and write. And the problem is to allow multiple readers to read at the same time and only one writer to access data. So the, for the for the process, we have I've written the code here, and the output is as follows. The third problem and the last problem is the Dynamic Philosopher's problem. The Dynamic Philosopher's problem is considered classic synchronization problems. The simple representation of the need to allocate several resources among several processes in a deadlock-free and starvation-free manner. Considering an example of five philosophers who spend their lives thinking and eating, the philosophers share circular tables surrounded by five cheese, each belonging to one philosopher. In the center of the table is a bowl of rice. So the problem is uh, that there's five single chopsticks and five philosophers, but each philosopher needs two chopsticks to eat from the bowl of rice, but they can only pick up the chopsticks one at a time. So uh, uh, of and the conditions that philosopher may only pick up one chopstick at a time, and that in order to eat they need to borrow a chopsticks from one of their neighbors. When the hungry philosopher has both chopsticks in her hand, in their hand, she can eat without releasing her chopsticks. When they finish, they put down more chopsticks, and the other philosophers may continue on. So this is the problem. So in this problem, we need philosophers to spend their lives alternating and eating. So we need them to not interact with their and bother their neighbors, but occasionally try to pick up two chopsticks one at a time to eat from a bowl. They need the so the problem is as follows, and I've written the code for it, and the output is as follows. Thank you for listening to my explanation.